This is the first of a three-part tutorial on using Eagle, which is a printed circuit board layout program that's available on Autodesk. So when you first open Eagle, you'll come to the control panel. The first thing we should do is create a project. So so File, New Project, and let's call it something. And then we're going to use the right-click menu to create a new schematic inside that project. Okay, the first thing we want to do is we want to add some parts. The problem is we are limited by the libraries that we use for these parts. So let's say we're starting from scratch and you have I don't know. So you have a bunch of libraries here. Usually Eagle will include bundle some libraries for you, and you'll have about 270 some libraries, which is very difficult to manage. So I think it's better if we just start from scratch. So remove all the libraries, and we're going to browse for some SparkFun libraries, because they have footprints for a lot of stuff that we're going to use. Okay, we need connectors, so we'll use that. We're going to need some resistors, let's use that, and power symbols. Let's see, I see power. There's power symbols. And today we're going to make a board that uses multiplexers for an Arduino project. So that's probably not available here. Let's see if we can find it somewhere else. So it's the 4051. Yep. No. There we go. All right. So now we have our libraries selected. We should be able to find the parts that we need. So the first is the multiplexer. So that's the 4051BE. Okay, so I look at this picture on the right. This is the footprint for the surface mount version. We have the dual inline package, the plastic dual inline package that uses through holes. So that's the part that we need. And we've got two of these. And let's see, we also need 4 resistors to add to the rotary switch. So you notice the picture on the right. This is for a surface mount resistor. It's it looks like a rectangular prism with soldered ends. What we want is something that uses through holes, a leaded capacitor with through holes. So that's not useful. Not useful. We're getting warmer. Those are, here we go, horizontal quarter watt, 5%. So this is the footprint that we want. So a quarter watt resistor, it uses through holes, so that looks good. And this value doesn't matter, we can change that. So I'm going to say OK. And I don't want it horizontal, I want it vertical. So I'm going to right click to change the placement to vertical. And I can just place 3 of these. Placement doesn't really matter right now. By the way, you can use your scroll wheel to zoom in and out, and if you press and hold the scroll wheel, you can pan the camera around. Alright, next we're going to need to add some connectors. So we need some 2x8 connectors to connect the Arduinos to the multiplexers. So let's use that one. I think we're going to need a 1x4 or a 2x4 rather. Really, we need a 5-pin connector for the rotary switch, but I ordered some Molex 8-pin connectors, and so I'm going to use those instead. So maybe one here for the rotary switch, and probably in between our muxes for the rest. So that looks like all the parts that I need. So maybe before I do anything else, I should save this. I have no idea. Okay, so now we have to start wiring it up, and this is where a few shortcuts will come in handy. One is Control M, so that's the shortcut for move, and that'll allow you to move the parts around. So I'm probably going to need a little bit more room for these parts. And the handle for moving things is the plus sign. Like if I try to grab it anywhere else, it's just going to ding. So grab it on the plus sign and then you can move it. It's just, there's some little idiosyncrasies with Eagle that are a little bit annoying when you're first working with it. So I use the select tool, and then if you look in the lower left hand corner, it gives you some directions. Left click and drag to define a group, and then left click to start defining a group polygon. So that's good. Now I want to move it, and the instructions are Control right click to move the group. So I want to move this group of resistors. Well, I've got to find the plus sign, and I use Control right click, and that allows me to move it down. Great. Okay. So this is pretty arbitrary, right? This is how we connect things to our Arduino is up to us. So we just need to do something that makes sense to us. When we wire things together, we're going to use the net command. So there's a shortcut key for that because we use it a lot. It's Alt-N. So Alt-N, or just hit that green net bar, and we're gonna go from pin 1. I'm gonna call this VCC. Oh, no. So once I want to stop drawing, I just click again, and then if I right click, there's a few things I want to do. One is I want to assign a name to this net. So that's under Properties, and instead of N1, I'm going to call this VCC. And I also want to label it. So I right click, select label, and I just clicked where I wanted the label. If I don't like it there, Control M to move it. I grabbed the wrong thing. Great, and then I've got some digital pins on the right, so let's do digital pins on the Arduino, D2 through D8. I don't think we're going to use D1 because we normally use that for serial communications.
The rocks and the riffles don't feel quite the same as I swim through this unfriendly place. So long in the journey and far from my home, but I still taste the tiniest trace. Raised in the headwaters, schooled by the banks, I leapt at my first chance to run.
So we're going to use pins 4, 5, and 6 for 5. Wait, did I label? Sorry, 5, 6, and 7. Ah, that's funny. All right. I said I wasn't going to use D1, and I ended up putting D1 on there. I think I'm probably going to delete that net, to be honest. Otherwise, we'll get a warning, which is no big deal. We'll just ignore it. But still. Okay, so Control M, I want to move this to give myself a little room. These are going to be the address lines, 5, 6, and 7. So use an Alt-N for the network again. I'm pretty sure 7 is our 7's our least significant bit, so actually that's wrong. So I need to, okay, so I had to select it and then go over to the trash can to delete it. Alright, so pin 7 goes to our least significant bit. Yep. And then 6 goes to B, and 5 goes to A. Oops. I got that message because I inadvertently clicked on one of these other lines, and so it asked us if I wanted to merge those two nets, and I don't, right? And, you know, there's no reason why those need to cross, so let's uncross them. We have any other connections to the Arduino? The output is going to go to pin 3. So okay, I think you get the idea. I'm going to go ahead and wire this up offline, and then I'll show you what the finished product looks like. Okay, so I added all these labels and lines. I actually changed the muxes so that they corresponded to what the pinout looks like on the board. Just thought it would be easier to route later, and so I added nets with labels for all the buttons that go to the pins. So go to the buttons, I mean. And what else did I do? Okay, I added a label for this, not the net, because if you select this and hit I or info, so here's the info button, it tells you that the name is A4, which corresponds to the input pin for the analog input pin. So I wanted to give this a more meaningful name on this silk screen that would tell us where it actually needs to be connected. So to do the name of the net, so I want to undo that, sorry. What I actually need to use is the text tool here, so that's this. So you can write whatever you need here. Okay, so we're basically done, but now I'd like to make sure that we don't have any errors. So there's a nice tool down here. It's the error checking tool. It shows you things that it thinks you might have done wrong. So well, we don't have any errors. That's unusual. Only one pin on net A5. If you click it, it'll show you where it is. If you double click it, it'll center on where that problem is. Well, that's okay. We don't actually have anything connected to that. I could remove it if I wanted. If I wanted to remove that warning, I could just remove that label because we're not using it. So that would make sense. All right, and these are potentially more serious, right? Because we have VDD, something that the library says this is not necessarily this pin VDD doesn't correspond to the name that you gave it on your schematic, which is VCC. So it's telling you VDD is connected to VCC. Make sure that's what you want. And then VEE is connected to ground, and we can verify on the data sheet that VEE actually can be connected to ground. This is the negative power supply, and VSS, same thing. Anyway, one of them is ground, one of them is the negative power supply, and in our configuration we can ground them both, so that's good. And then J1 has no value, that's fine. Okay, and then these are overwritten with ground. That is also good. So I can either clear all of them or approve all of them. I'm just going to clear all of them. And it tells me I overwrote this signal with ground because originally maybe I wasn't careful when I first laid down these wires and I didn't set a name for them. And so it'll sometimes pick a name, or it'll pick 3.3 volts if it thinks it should be a supply line. And so you have to go in later and overwrite that. And it took me a while to figure this out, but if you right click on this and select properties, and then you go in here and you try to change the name. Oh, that's funny. It let me do it. So once again, I'm learning a new thing. But normally it won't let you do that, right? You have to know the thing to click, and you select the name that you want it to be. So if you change the name from a net to a new name, normally you'll get an error saying you have to use the name command. So that's what you do, is you right click and select name instead and give it the name of the new net. Alright, well, I think we're now ready to do the layout. Once you've got your schematic confirmed with no errors, then the very next thing that we're going to do is we're going to generate a printed circuit board by clicking this button. But that is the subject for the next tutorial. Alright, take care.